All right, let's begin. So the first thing that we started with was the star. I started off by taking the two triangle demo and I made the square. And after that, I made 4 additional points, each of which is at the center of the edge of each part of the screen. When I did winding, again, I followed the 2 triangle demo for the square, followed by making the 4 triangles, each winding counterclockwise appropriately. As you can see, looks like what we saw on the website for the assignment. Next up was the n-gon. Started off with an even one. The way I did this was I created 2 arrays, one to store the x values, one to store the y values, which was based off the sine and cosine respectively. I stored the halfway point because I wanted to make sure at the halfway point that it was set up properly, which will be more important for the odd numbers. So first I put in the 0 and then I started with half of them. Once I got to the halfway point, I just did this as an insurance before I had it -1, but because I wanted to standardize it to show it more. Then I continued on for the bottom half of the n-gon. And after that, I stored the vertices. And once I stored the vertices, I moved on to the indices. The indices, I found the size of it based off of the number of verts minus 2 times 3. This is because the number of triangles we will have is equal to the number of verts minus 2. 3 verts, 1 triangle, 4 verts, 2 triangles, etc. And I multiply by 3 because we're storing every point on the triangle, so we're storing them in triplets. I added them to the indice list by starting at 0. The position was the current vertice times 3. To make sure we didn't overwrite any triplets, I made the triplets starting at the position, add 1, add 2, that gives us the 3 allocated spaces. And then the triplet, it goes as 1 higher than the current vert, 2 higher than the current vert, and then it ends at 0. We end at 0 because we always want to end at that first vert. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 verts. And the way that I worked with odd was I mimicked what I did for the even, but I added 1 to the halfway point. The reason why I added 1 to the halfway point was because if I didn't, then the first vert and the last vert would overlap each other, which would not give us the n-gon that we wanted. So by adding 1 to the halfway point, it makes sure that every single vert is drawn. So here now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, which as we can see is what we set it to. Finally, for further work, the reason why when we set the top vert to 2, we get a trapezoid is because the clip plane is set at a z-value of 1. When we set anything greater than 1, the vertex is behind the clip plane. It does not get shown on the screen. The code still wants to try and draw this triangle, though, so it will draw that point. It will draw that line, draw the line to that top vert. Once the line reaches a point where its z-value is greater than 1, it's no longer shown on the screen because it's behind the clip plane. Same with the bottom right vertex. The reason why we get a smaller triangle is because the vertex is now behind the clip plane. The line tries to draw to that bottom right vertex. Once the z-value gets greater than 1, it will no longer show on the screen. As for the top left, the reason why we wouldn't want to show everything on the screen at once. This could be for things such as if we want to zoom in, zoom out feature, or if we want to pan around a scene, or if we just don't want to render everything at once because it's unnecessary and it could waste resources. It sometimes is more valuable to not render the entire screen based off of what the actual scene is. Finally, RGBA unorm, we use that. It is a 32 unsigned normalized integer with 4 channels, red, green, blue, alpha, each of which with 8 bits. And unorm is an unsigned normalized integer, which means that it represents any number from 0 to 1 based off of however many bits are flipped. So no bits is 0, all bits are 1, anything in between is some decimal between the two. Finally, we use RGBA norms because we are creating colors and we want to know how much percentage of each color, red, green, blue, we want. And if we want transparency for the color, that's where the alpha channel comes in. Then we have the R16 uint. R16 uints are unsigned integers of 16 bits where all the bits are in the red channel. Uints are unsigned integers from 0 to this large number, which is different from signed integers, which have half of them negative, half of them positive. The negative is based off of the most significant bit. And finally, we have the reason we use it is because, for our case, we are using words, which are 16-bit, which is why we're using 16. It's unsigned integers because we're storing indices for the index buffer. The indices cannot be negative or decimal values. They're always positive integers. And we're using the red channel because that is what the index buffer supports.